Alright, so this is going to be my last example for this bracket of material. So the context, we're talking about energy and pollution. So a really dramatic change that we've seen over the last few years is people installing solar PV in their houses. And one of the things that we might like to think about is, does this change people's behavior once you have installed these systems on your house? So do you then consume more energy? Do you consume less energy? Or do you consume the same amount of energy? So it is, an interesting policy question, or something that we're broadly interested in around what's happening. And it's sometimes we worry about rebound, what are called sort of rebound effects. So we install something that is a little bit more sensitive, and then because we've done that or our costs go down, we use more of it. So that would be in energy. So if you look in the marketplace, we see these things on TV, but we also see these, this is sort of taken from a flyer that is promoting some people, and they're saying, hey, these are the different systems you could install, and these are the benefits that you will get if you install this. So you'll be, they talk about being independent from the energy network, and you'll have your own energy supply. They appeal to people wanting to reduce CO2 emissions. I've just framed this as this warm glow. I mean, they kind of say these things about what you will get. There's they talk about sales. They also talk about lower bills that and that depending on the way the system works, you might even get paid rather than having a lower energy bill that you'll actually get credit. And they talk about these things that I think allude to being conservation conscious, or appealing to this aspect. I mean, that's, I might be wrong here. That's my take on just reading a couple of flyers. And this shot that you can see is a shot there. I've cut off the phone number of the place to call if you are interested in this. But look, it's an active area of interest, really dramatic changes in energy, lots of dramatic changes to come, most of which are in a positive direction. Okay, so we might be looking at something about what kind of changes in energy consumption take place. This is some access to some data that has gone on, so you can see that there's quite a bit of data that you can get about systems. One of my colleagues along here is very good at scraping data from online. It's very, very clever systems, but this is an example of logging in as someone. And this is, the output that we're seeing. This is the energy being used, produced, and all of this. So we get all of this interesting kinds of data out there. What are we interested in asking? The question that we're interested in asking is, what happens to energy use once you install PV? So do people then go, oh wow, I've done this, now I'm going to use more, I'm going to pay less attention to being conscious of the amount of energy I consume. I've got solar PV, so I'm going to be very relaxed. I'm going to use more energy. So there's this kind of interesting dynamic that people are trying to find out about is, so, if you installed the system, does that mean that you were conscious of your energy use, or does it mean that you want to use lots of energy and that's why you got this system? So it's a before and after setup. So what we've got is we get a measurement on energy consumption before you install PV. We get a measurement on energy use after you install PV, and we look at the change. So that is a paired t-test. We've got this, systematic grouping by household, before the PV, after the PV. So, you can see where that kind of before and after expression comes from. What's the plot that most naturally suits this? I tend to think that the plot that most naturally suits this is the horizontal box plot. And that's what I've got here. And for me, this is really informative. So what I'm looking at is this plot here, and I can see that most of the data here is sitting around 0. So for me, just on a visual inspection of the data, it says that I don't think people are changing their energy use once they get solar PV installed. So let's have a look though. Not everyone is going to be convinced by that. I hope that you find that that's reasonable. I would think that this would be a very effective visual for convincing people that energy use hasn't changed once people have installed solar PV. But we want to have a formal test. So the mean of the different series is 0. Okay, so what does that mean in practice? It means that energy use hasn't changed after you've installed solar PV. always going to apply the p-value decision rule at 0.05, so that's alpha, conduct the paired t-test. So it's as simple as that. So I've got my before, so WA1 and WA2. These are my variable columns, so I have my ID identifying the household, and that would be my rows. My column names are my variable names, WA1, WA2. So I've got two measurements for WA, and I want to apply a paired t-test. So that's what we've got going on here. You can see then we just look at the p-value. P-value is 0.89. We don't really worry about it. We just say it's above 0.05. That means that we reject the null. Oh, sorry. Scrap that. We do not reject the null. Okay. So p-values, we would say the p-value is above 0.05. Therefore, we do not reject the null. Or you can say the language that I use in the notes is that we have insufficient evidence to reject the null. And that's kind of a good way to think about these things. So that's the last example that I wanted to cover in this bracket of material, and that's a good time for a break.